we're trying to do is really make the world a better and safer place for people and animals. InnovaPrep makes tools for modern microbiology. Our process work using an innovative filtration method for concentrating particles from a liquid. So right now what we're doing is moving from concentrating particles for industrial purposes, such as looking for contamination in beer or consumer products or food safety or drinking water or even wastewater monitoring for COVID. We're moving from that into the clinical space, and we've targeted urinary exosomes and other exosomes for body fluids as our primary thing that we're trying to do. So InnovaPrep is all about innovative preparation. So it's the sample prep portion of that work is what InnovaPrep does. We can take a real world sample like a urine specimen or a water sample out of a lake or a can of beer and concentrate that into a fraction of a drop so that the target material is there for them to analyze. Ended up here in the Innovation Park partly as a Jayhawk. I just had my eyes on KU and what's going on out here, and I was amazed to see when the park was coming together what was happening out here. And I knew of a company called Clara Tech that I knew the founder, Jim West, through Pipeline Entrepreneurs. And when he was selling Clara, we bought it because we had identified this opportunity in exosomes and an opportunity to help fight cancer. And identify cancer earlier by using the concentration process to make the sample more amenable to early detection by increasing the concentration of the target molecules that might target particles, the target exosomes that might indicate cancer. We started out in biodefense, really is where this started out with. We have big biodefense contracts where we help take real world samples and help the government, Army, and other services analyze for threats. But that's gone further now into consumer products, even things like beer and wine, water and wastewater analysis. And so exosomes in the clinical market is just taking that to an even more personal level to try to say, what can we really do to help fight cancer and to try to do something about, for example, early detection of pancreatic cancer. Pancreatic cancer can't be detected usually in most people until they're symptomatic, and by then they might be stage 4. And that's almost too late to do anything. But if we could identify it at a stage 1, then maybe more could be done. And I think that handshake between the cancer diagnostics and the treatments is a real one. And so we would like to really help with not only the cancer diagnostics and by helping solve the math problem of the dilute exosomes in the urine, for example, but also help with the treatment. In Drexel, we have engineering labs and we have our manufacturing facilities to make the microfluidic devices that actually are the heart of the concentration process. Here, it's just all about the wet lab space. We call it ACE, it's our Application Center of Excellence. When we're working in Drexel, it's a hive of activity and everything's happening around the manufacturing process and the business. When I come out here to work in the park, it's strictly about the innovation and inventing our way into the clinical market, which is completely new for us.